This is patch day number 9. I'm going to start this exactly the same way I started number 8. I'm going to get myself an easy ADC. I'm going to get myself an easy DAC, and I'm going to make something in the middle called a PFFT. I guess this time with our PFFT we're going to create an abstraction where we basically, I'm calling it a P-Voc delay, a pitch vocoder delay, but it's sort of just a live application of the phase vocoder that's already with your Max world. So if we go and find that abstraction, we can go and destroy it. All right, so on your I don't know where exactly Max is installed on a PC, I've kind of forgotten, but in the Max 5 folder you have examples, and you have FFT fun, and you have phase vocoder folder. I mean, we could have a quick look at what this thing is, the phase vocoder that they like you to open, the phase vocoder sampler. It all looks really fun. You load in a sound file and play it. I'm sure most of you have played with this already. And then it says at the bottom, although I can't get that up here, can I? Yes, I probably can. It says at the bottom, nope, I can't get that visible. It says at the bottom that you know, abstraction can also be used without the B-patcher interface, and I guess it's implying that you use, one second, where are we? Okay, so it implies that you're going to use this thing here, which we'll see is the pretty much the entire guts of that B-patcher. Well, it is the entire guts of that B-patcher. Again, less useful. With thing we want to actually play around with is the abstraction load, and in here the P-Voc samp. So let's go ahead and open that up. Where am I? Again, we're back here in the lib folder, the P-Voc samp abstraction, which is where all of the work is actually, well, the interesting, the important work for this is achieved. Okay, so the first thing we're going to do is just cut a whole bunch of the stuff out of this, because essentially what we're going to do is, instead of recording it, which is what happens in that phase vocoder sampler, instead of just recording that to, you know, loading in a file and recording it, we're going to have this sort of record continually on the fly, so to speak. So first thing we can get rid of is that record, and then we can get rid of a whole bunch of other stuff associated with the loading in of the file, all of that. And we can also get rid of this, and what we should be left with is this. Since we only have now, well, essentially 2 inlets, which will be our FFT in 1, in over here can be changed to number 2, because that'll be the second inlet. We also don't need this, I guess. That outlet can disappear. It's only there for, you know, for looks anyway. So yeah, we're going to take this thing that was the real but is now the amplitude, sorry, and take this, which was the imaginary but has become the phase, and then the difference between phases in successive FFT frames. I'm sort of reading that, and then that's wrapped around 0 to 3, no, negative 360 to 360 degrees, or I suppose more accurately, negative pi and pi. Okay, just to start off with, I'm going to use the same object as we did in the patch of day number 8, which is the poke tilde with the name this, I guess, since that's the buffer that's been created here, with the argument 1 for the channel 1. Again, this is a stereo buffer, and we're going to take this information here and poke it into the left side. It's read out, as it was in that previous tutorial, it's read out at the other end using this using the index tilde, and then this stuff here is just the inverse of what happened here. I'm sure mathematicians in the family can help you explain that whole process. And again, what was the imaginary and is now the phase, or difference in phase, the deviation in phase is what they like to call it here. We'll poke that into the second channel of that buffer. And what we're going to do to get the index to store these is very similar to what they're using here to read them back, which is we're going to take this thing and we're going to add it to something which is a kind of a counter going, let's say, to 1,000. So that'll be we'll be storing 1,000 frames of FFT data, and to get this counter to move every time this thing gets to 0, we're going to make an edge object, which we'll see. We can hook that up. We can see that it has two outlets: output on 0 to non-zero and output LED on non-zero to 0. It won't really matter too much, but we are interested in the non-zero to 0 because that's when this FFT, this index, wraps around. Okay, so that's really good, and we're going to want to multiply this value here as they do here by the spectral frame size. So actually I might just grab that and duplicate it. So that by that should be good. All right, I can make more space here if this is getting hard for you to read. All right, that might be better. Okay, and then we're going to multiply the actual index value by this. Again, this is what they do here. All right, actually I'm going to grab that. So I can multiply this by, does it matter which way around this goes? I don't know, this might make more sense. I don't know, who cares? That by that, okay. And we're going to use that as the sample index to poke. So we're going to be continually, for 1,000 frames, continually writing those these amplitude and phase deviation values into the poke buffer. Okay, this all looks ready to rock and roll. I can save this as, be careful at this step, if you save it the way it is now, you'll have destroyed your Phase-Vocoder sampler example and you'll never be able to do it. And I don't know what will happen, probably nothing. So I'll call it Phase-Vocoder in my folder. You'd have to reinstall Max is what would happen if you obliterated that one. Okay, so we can go back and do a Phase-Vocoder over here. We'll give it some arguments. This is again the size of the FFT, and we're going to use 4 overlap on that bad boy. It didn't open it up, as we can see in the Max windows complaining, no patcher. Okay, we have to do as we did in the last tutorial. We need to save as, and we'll call this my Phase-Vocoder. Now again, if we reinstantiate that, type in that 4 again or do something to it, we'll see it has inlets and outlets. We can double click it to see what the abstraction is, and it all looks good now. And the only other thing we're going to need, or I think we're going to need, is an integer coming in here to tell it which, so I for int, to tell it which frame we're wanting to read back out of the buffer. Okay, so we can turn this on, and if everything is groovy, we should be able to hear ourselves in slow motion, or we can read backwards through that thing. That's all good. You can see where we got to the end of this thing. Alright, I'm assuming there's some kind of algorithmic control on your patch that you can do to make this truly a live performance wonder. And I'll catch you in the patch day 10. Bye.